So today's topic is going to be simultaneous linear differential equations. Now first of all, what are simultaneous linear differential equations? So the linear differential equations having two or more dependent variables with a single independent variable are called simultaneous differential equations. Now we are going to see how to solve these type of equations. So we will do this by means of the example. Supposing we have to solve this given system of equations, dx by dt plus y is equal to e raised to t, and the second equation is dy by dt minus x is equal to e raised to t. So over here what we are going to do, we are going to rewrite these equations by making use of this d operator. So d is d by dt. So we will rewrite the equation like this: dx plus y is equal to e raised to t, and we will call this as equation 1. And then the second equation we will write as dy minus x is equal to e raised to minus t. Here it should be e raised to minus t. Okay, now this equation we will call it as equation 2. So what we are going to do is, here we are going to multiply this first equation by d. So you will see what is the use of doing all this shortly. So first we will multiply 1 by d, and this will give us d square x plus dy is equal to e raised to t. Remember, d is the operator d by dt. Now what we are going to do, we will call this equation as equation 3. Now we will subtract 2 from 3. We are going to subtract 2 from equation 3. So subtracting 2, so this is 2 from 3, or in other words we are doing 3 minus 2. So what this will give us is d square plus 1 into x is equal to e raised to t minus e raised to minus t. So just you are advised to do this subtraction, 3 minus 2, and this will give you this equation, which I am now going to call it as equation 4. So this is a linear differential equation with constant coefficients, as by now you must have already identified. So it has to be solved by the usual method, which is of course to find the CF and the PI, and that will give you the solution of the differential equation, right? So first of all we are finding the CF. So how to find the CF? For that the link is being given to you over here, so you can just refer to that link and see how to find the CF. So I will directly now write over here CF is equal to C1 cos t plus C2 sin t. So that is the CF. Now for the PI, obviously once again the link is being given to you of how to find the PI, so please refer to that. So this is the function, it is given in terms of t, therefore I am writing f of t. Now this is equal to 1 upon d square plus 1 e raised to t minus e raised to minus t, and this one you have to solve. So if you have to solve this separately, so after solving this you are going to get the PI as half e raised to t minus half e raised to minus t. So once again you have to go back to the videos for which the links are being given in the description box, as well as over here also I will provide the links. So you just click those links and go back to how to find the CF and the PI. So in this manner, the complete solution of this equation which we had formed, which is equation number 4, which is the linear differential equation with constant coefficients. So the solution is of course the CF plus PI. So x is equal to C1 cos t plus C2 sin t, right, plus 1/2 e raised to t minus 1/2 e raised to minus t, and this equation I am going to call it as equation 5. Now we are going to use 5 in equation 1. So if we use 5 in 1, we are going to get d of, so please go back and see what was 1, d of C1 cos t plus C2 sin t plus 1/2 e raised to t minus 1/2 e raised to minus t, and then we had plus y is equal to e raised to t. So this will imply, so d is the operator d by dt, so this will give us minus C1 sin t plus C2 cos t, then plus 1/2 e raised to t. That means we are finding the derivative basically, because capital D is the operator d by dt. So over here minus plus 1/2 e raised to minus t and plus y is equal to e raised to t. So now just we will shift the terms to the RHS. That means these terms I am going to shift to the RHS so that I will get the value of y. So y is equal to now C1 sin t minus C2 cos t, okay, and then after that plus 1/2 e raised to t. Why? Because e raised to t minus 1/2 e raised to t. So plus 1/2 e raised to t minus 1/2 e raised to minus t. And this I am going to call it as equation 6. So now we have got two equations. We got one equation 5 earlier which you can refer to. And now we have got equation 6. And 5 and 6 together are the solution of the given. 5 and 6 are the solution of given system of the simultaneous linear differential equations. So this is how we have to solve the simultaneous linear differential equations. Now for practice, you can try to solve this particular system of simultaneous linear differential equations. So dx by dt plus x is equal to y plus e raised to t, and dy by dt plus y is equal to x plus e raised to t. Thank you and have a nice day.